Welcome, everybody. If you're watching live, as always, please feel free to ask any questions along the way. If you think you might like to come on the show yourself, please do get in contact. My details on the channel's About page. Next week, we'll be talking with Tom Fleet, but today's guest is Bradley Gawthrop. Hello, Bradley.
Howdy.
How are you doing?
I'm doing well. How are you?
Great. Yes, fine, thank you. Yeah. Would you like to just introduce yourself, who you are and what you do?
Sure. I'm Bradley Gawthrop, and I design open source hardware for FieldKit, which is a project under Conservify.
Fantastic. Thank you. So as always, I typically start my shows with those exact words, and I need to find some new words. But I like to start with sort of childhood and where people started from. Can you just give us sort of an overview of what your childhood was like and what you got up to, what your interests were? That kind of thing?
I mean, I was the youngest of five. It was a very bookish house. There was lots of books and lots of music. We were all five of us homeschooled, and that was sort of the atmosphere. And I hit a lot of the cliche points of the taking apart of random things and the sort of things that you expect to see in that sort of environment. I don't think I ever felt really smart until I touched a computer.
Okay.
Which helpfully came fairly young. But Dad is a classical music composer. That was he was an up and comer at the time when I was young, but made a success of it in the interim. And so it was all sort of quiet and bookish.
Okay.
It was a nerdy house, sort of unapologetically so. And my siblings were all quite a bit older than me, so I think maybe one of the reasons why I floundered around a bit is because it was 5 years between me and my nearest sibling. So
were they sort of off doing things and you were sort of following
right?
along
I think they'd all found niches.
Yeah.
Not surprisingly, right? Like again, a long head start. So, like I say, I didn't think I really had the stuff until I found something that I could sort of see all the way through, and that was computers. We ended up with a computer quite by coincidence. Dad needed one for doing manuscripts, for music manuscripts. We were not in the sort of socioeconomic strata that would normally have a computer in their house in 1990. But it was a work thing, and so we had one, and I got hooked.
Awesome. Was that sort of a difficult thing to share with your dad at all? I guess it was primarily for his work by the sounds of it. And therefore, they
were pretty good. I mean, mom and dad had raised 4 other kids by then, and they knew what obsession looked like.
Right.
I was keeping odd hours as a kid anyway, so it wasn't too bad. I mean, by the time it really mattered, they'd figured it out and maybe upgraded a little sooner than they absolutely needed to in order to make sure that I had a machine that I could really hammer on full time.
Amazing.
They were considering our limited means, they were remarkably effective at making sure that I could get my hands on hardware and software.
Fantastic. And what kind of thing did you get up to with the computer?
Oh gosh, well,
was it music following in your dad's tracks, or?
No, I mean, computer music wasn't much of a thing at that point, at least not for us. And of course, he was doing engraving with it. He wasn't doing the composition with it. He composed on an electric organ, a Yamaha, which is also a fascinating confluence of technology and music and electronics. That organ is interesting. I actually bought the same model last year to have, because it was an early entry point into those interests for me. But the composition didn't happen there. No, when I got to the computer, I hit a little bit of programming, and mostly just sort of, I mean, it was not quite to the BBS days yet. That would come a little later.
Right.
But there was, I mean, it was the heyday of shareware. And so there was a lot to fiddle with, and programming was reasonably accessible at that time. This was like a 386/16.
Right.
Giant metal tank of a machine from Northgate.
Okay.
And so, there was plenty to play with. By the time the hardware moved along a little and the software moved along a little and my knowledge moved along a little, it was graphics, ray tracing, programming, and networking in the early days, when that really meant telecommunications. That was bulletin boards and stuff. I was the teenage sysop. That was.
So you've touched on two things there. There's the graphics side of things, which I think you actually sort of progressed and did quite a lot of graphics design. Can you just expand a bit on that for us?
Yeah, I spent quite a few years as a freelance designer. I still have a couple of clients who I take care of when their projects come up.
Mm-hmm.
I did a lot of print design for CDs. Kids Ask Your Parents what that was like. And quite a lot of print layout and design. Of course, Dad was publishing his own stuff, so there was a publishing company to hand, which needed lots of promotional stuff. So there was never any lack of things to do.
Okay.
So laid out catalogs and all that kind of stuff. And then on the digital side, we were just coming into the days of ANSI graphics first, and then Rip Script, if anyone remembers that, the first attempt to bring graphics to bulletin boards. Oh my God, it was dire. Really, really bad sort of pseudo PostScript language, and then the very early web, which is how I first scored a paying gig, which was a combination of developing websites for my dial-up bulletin board and administering their mail servers under FreeBSD. Which was an education of a kind, because the idea of the difference between production and not production did not exist in those days.
Right,
so you were playing with live ammunition all the time, which was pretty exciting.
Okay, and was this kind of sort of late teens kind of age, or was this
pretty early teens? Let's see, I was born in 81. We got the first computer, I think, in 90. So by the time I was on bulletin boards or working for the bulletin board, I would have been 15, maybe 14, 15, somewhere there.
Yeah, very cool. And you mentioned email servers. Does this mean it's sort of a small ISP with a largish number of people, or were you responsible for their communications effectively?
350, 400 customers at that point.
Wow, okay.
When I got hired, I think it was 15 or 20 lines. It was like literally run out of the guy's house.
Yeah.
And most dial-up internet service providers at that point were small affairs like that. They'd grown out of bulletin boards that people were running out of their houses. And there was a lot of ongoing speculation as to whether the net was going to amount to anything, which we can see how that one turned out. Well, the web was the one that was deeply controversial because we were all used to working from the terminal, and this hypertext stuff seemed a little out there. I was an early adopter, but there were lots of skeptics.
Okay. Very good. And then from the sort of those days with email servers and the graphics design things, what happened next?
Spent some time. I did 3D renderings for an engineering company for a while.
Okay.
I started working full time at 16.
CAD and things, or was it sort of
They were doing CAD, and they were handing me models that got rendered out for pretty glossy pictures to impress people with. So that was my department. So they would hand me solid models out of SolidWorks. Which, if you think SolidWorks is a stinker now, you should have seen it in those days. And I took it to renders in Cinema 4D in the very early days of that platform, 1.0. So I did those for a little while, and then we moved kind of out into the middle of nowhere, and I drifted out of technology for a living for a while. I ran a music store for a while. I went from the bottom to the top of that one, and printing for a little while. And then I found myself living in Richmond, Virginia, when it was really a slum and where gunfire was a commonplace. And I had some unfulfilled itches. And one day, a block over from us, two guys got in an argument over a pack of cigarettes and emptied their respective 9mm clips at one another at a distance of maybe 5 meters, injuring one of them non-critically, and the rest of the bullets just going into the general area. That's what happens when you hold your pistol sideways, I suppose. I was ready to move at that point, and so I decided my father, before being a composer and before I was old enough to take any notice, had been a pipe organ builder.
Okay.
And so I had inherited the books about that trade and had read deeply. And I thought, well, if I'm going to give that trade a try, now is the time. And so we moved to rural Tennessee. I started up with an organ builder there, and I spent 12 years in the trade.
So just to clarify, this is organ that you'd find in a church, that kind of thing.
Right, actual windblown organs.
Yeah.
Big piles of whistles.
Fantastic. I love them.
They're an amazing thing.
Yeah. So how did you get on with that? Was that something you enjoyed, or you
I
did
did.
because you sort of fell into it, or how did that go?
I love the trade. Well, I mean, I knew I'd wanted to try it. It was sort of the confluence of all of my geekiest interests. The organ trade is a bit like the special effects trade in that it absorbs, a dozen other trades in and of themselves. So to be a good organ builder, you have to be a very good woodworker. You have to know a lot about everything from metallurgy to electronics to any number of trade skills. You're hoisting big heavy things high in the air, so you'd better be a pretty good rigger. You have to have a good ear. You have to be able to tune in voice. There's design for all these things. They're incredibly complicated machines. The ones that we were building were electrically driven, so there was all of the electronics that goes along with that. There's a whole history and an artistic tradition you have to be aware of to design an instrument that's good for anything. And so, yeah, it was, a sort of bottomless trade. And my besetting vice is boredom. So a trade where there's always more to eat up seemed too good to be true. So I jumped right in, and I enjoyed the trade very much. It's a dying trade. And the economic writing was on the wall.
Right.
And in the course of those 12 years that I spent in the trade, I worked for 3 different firms. Every one of them went bust. The middle one was mine. Okay. And I decided it was time to go home to technology after that. But I certainly don't regret the time I spent in the business. I learned a great deal, and actually, weirdly enough, came back around to electronics because of it.
Okay, fascinating. So before we move on, are you happy to sort of dive into pipe organs? Because they're one of my probably most favorite instruments. I love them. And I'd love to hear more about what goes into making, designing, fixing, that kind of thing.
Well, there are a lot of different sort of traditions in that business. It depends on what you're going to build. The first thing that I was doing was a fairly contemporary style of instrument. So large boxes of pressurized air with electric solenoid valves essentially immediately underneath every pipe. Which is called a unit action, which in some ways is simpler to build than a purely mechanical organ front to back. It's certainly more flexible to build, and it's certainly easier to play because you're not fighting against the collective air pressure of every valve that you want to make sound. And so there's a lot of electrical design. There's a lot of mechanical design. I did a lot of CAD in that job, and there's also a lot of very nasty, grubby work in hot organ chambers, high up off the ground with bad safety equipment and that sort of thing.
So did you find yourself typically doing new designs, or was it repair work, or part of it's broken, therefore we need to replace a small part of the organ?
The first company, I mean, you do some service, but the first company I worked for was doing rebuilds of older instruments, rebuilds and expansions with varying degrees of sort of restoration sensibility and new instruments from scratch. Probably more rebuilds than new instruments, but we certainly did some of both. And of course, consoles, which is the pretty furniture part of the whole affair, and they did a fair amount of casework, which is the large scale pretty furniture part of the whole affair. So I bounced around all the departments at one point or another. And they had originally brought me in thinking to have me do research and development, which was kind of a dry well in the organ business for a while. It's conservative culturally, not politically, though also politically oftentimes. So they wanted to push the envelope a little. They were a little more progressively minded than that, and they wanted somebody to do that. And they wanted that in theory, and then in practice realized that research and development is expensive and time consuming.
Right.
And that it turned out that they didn't have the appetite for that they thought that they would.
no budget available, that kind of
And
thing.
yeah,
Yeah,
well, I mean,
like
it takes time. Like you go
yeah,
through. I mean, they were getting annoyed when things would go to a second or third prototype, and
right, right,
that's not really plausible as a way to do that kind of engineering.
sure,
So
okay,
helpfully, I ended up being a pretty good organ builder in general terms, so I was valuable to them elsewhere. So I ran crews for installations. I built stuff. Um, did a lot of tuning and voicing for them, that sort of thing.
hmm
And then they went through one of their periodic cycles of bust that followed the periodic cycles of boom when the order books were full, and laid me off. And so I started a little firm of my own,
okay,
which ultimately brought me around to electronics.
amazing. So you mentioned that you've got solenoids and things for controlling the organ. Presumably, historically, that would have been wires and pulleys and things.
Sure, the evolution of that sort of went from levers for the most part,
Okay,
levers and pull down wires, which are thicker than we think of wires as being rods, really.
right.
And from there, you go through a variety of sort of staged pneumatic actions. Of course, you have
hmm
big boxes of pressurized air anyway, so it's always tempting to try and use them for motive force.
Okay,
Because like you've got all this pressurized air for free.
yeah.
So like it's always tempting to build something that's like a 2 or 3 stage pneumatic so that you can make the small moves at the organ console move big things
hmm
without quite so much work from the organist. So there was a whole generation of instruments that were, full of little tiny lead tubes that went out from pilot valves out to, successively larger valves and stuff like
Okay,
that.
okay.
And then electricity hit the pipe organ, actually in England, thanks to a really wackadoo guy called Robert Hope Jones,
Okay.
who was a sort of electrical genius. He'd basically invented the British version of the telephone switch stack,
Right.
and worked in telephones for a long time, and then got bored with that and went to pipe organs there, and then here in America. And so he led the charge to electrify that machine, which was greeted with significant skepticism.
Okay.
He was swimming upstream on that one, but
Oh,
he won out. And so at that time, of course, the power was not, I mean, we didn't have transistors yet.
mhm.
Options were limited. So
Yeah.
for the most part, what you had is a bunch of switches in the console under the keys and draw knobs and things like that. And those were running little itty bitty pilot valves that were had a little pivot disc against a seal that was drawn up away from its seal by a small electromagnet. So you could run the whole thing on like 6 or 7 volts. Like
Okay.
he ran them on dry cell batteries.
Wow.
And the rest of the work was done pneumatically through staged pneumatics. But by the time we come up into the 20th century, we were building proper solenoid valves that would sit right underneath a pipe
Mhm.
and just open right under it. So then suddenly you're in just a terrifying wiring situation.
Yeah.
Thousands and thousands and thousands of wires, and that's called direct electric. And in between the two, there were various, evolutions of electropneumatic action, but like
Sure.
large anaconda cables out of the backs of consoles were the standard for a long time,
Amazing.
and big switch stack affairs that resembled telephone exchanges very strongly because the technology was largely the same.
That's very interesting.
So
Okay.
big switching apparatus that had to be, wired in painstakingly, and
Mhm.
gang switches of little gold wire fingers going into shorting bars and that sort of thing. It was crazy before the
Okay.
transistors. I've restored instruments from that period to
Yeah.
their original function, and
So did you
it's astonishing, but it's also Byzantine.
yeah. Did you give some sort of idea of scale? Can you give us sort of example of the number of controls and inputs, alongside the manuals and the keys that you've got of an organ?
Sure.
You know, how many
Obviously,
things
it
are
varies. There
involved
are
in
small
this?
organs and large organs, but
Yeah.
anything that I don't think I ever worked on a single manual instrument. So every
Okay.
instrument I ever worked on was 2 or more keyboards, up to as many as 7 in the real monsters,
Mhm.
and then a pedal board for the feet,
Yep.
which is essentially a short compass keyboard arranged under your shoes, and then draw knobs on, usually either side of the keyboards to turn individual sounds on and off on individual keyboards. So that's essentially just like a drop through matrix, this sound on this keyboard at this pitch.
Right.
And then because you don't want to be out here fiddling with draw knobs in the heat of battle when you're trying to actually play notes, by the time you get to the late 19th, early 20th century, people are building what's called combination actions, which are just essentially memory systems. So little round buttons under the keyboards that you can hit to get presets of draw knob controls, so that you can hit that without having to take your hands off the keys. So that's how guys like Ernest Skinner in like 1915 were building 1 and 2 kilobytes of pneumatic RAM.
That's awesome.
Or actually not quite RAM. I mean, it was persistent. So it's, something a little more like Flash, I guess. But like gigantic horse size pneumatic devices, which could store and recall those
amazing
combinations. It's just shocking stuff. And they drew it all without CAD. Like,
yes.
The intricacy level of all of these machines with little, cams and all kinds of crazy nonsense on a drawing board. Like, it's an industry that will cure you of the notion that you're any smarter than your forebears, because I couldn't do that with a gun to my head.
Right. Amazing. So I guess in sort of modern, in inverted commas, organs, there's a lot of digital control and much more simplified wiring, that kind of thing. Is that correct? Or is that sort of an expectation which hasn't quite...
I wish it was more like that than it sort of oftentimes is. The best control systems that are out there right now, out of the back of the console, there'll be a fiber optic cable. And that will wend its way through the organ chamber to various, decode boards. But one of the problems that you have in a trade that goes back that far is the temptation to design everything to look like the thing that came before. And so you have a lot of things like, because in the old days, the switching equipment was big, it would tended to be located in some corner of the organ chamber that was not used for anything else, and everything was wired back to that point.
Right.
And we sort of never grew out of that as an industry. And so even now that the electronics could be compact enough to go even in the enclosed air volume, or certainly very close to it, instead we're running gigantic cables out of those chests, usually telephone cable, 50 pair. Wired all the way back to some set of switching equipment somewhere in the chamber. And it's stationary, so that cable's fine. Like, it's not going anywhere, but it's a lot of work, and it's a lot of work that has to be done on site where the work is expensive. But yeah, so what you'll typically find now is, a lot of wiring in the console from all the controls back to some set of serializers, essentially. And then a serial signal back into the chamber, hopefully. The extent to which that's adopted varies. A lot of those systems are designed like it's 1972. And then back in the chamber, the opposite, essentially a deserialization process that breaks it out into all of the valves. That's when you're doing direct electric, so you have a valve under every pipe.
Amazing. Very cool. Thank you for the insight there. That's
sure.
It's amazing. I know that Sam from Look Mum No Computer, he's been playing with an organ, which is amazing to watch. I'll try and link that in the show notes if you like, just as a sort of a reference.
I chatted with him a little bit on Twitter about that project. He's been doing a bang up job. He's got great instincts. He is wise not to be in the business, but he could have been. Right. Got all the right skills.
Yeah, fantastic. Very good. So, do you play the organ? Is that a leading question?
A tiny bit. The way I used to always phrase it was that I could demonstrate an organ without embarrassing myself. There's something about that, something about sight reading well. It is a skill that I have bounced off of repeatedly. I've made several goes at it. But I just don't seem to have the stuff. I'm better than I used to be. I've been practicing more in the last few years, but not so as anyone would want to hear it other than me. How's that? I spent an hour with the sheet music, just absolutely grinding my way through Auld Lang Syne at the turn of the year this year, just to demonstrate to myself that I could. But it was not pretty. Yeah, I can noodle well enough to demonstrate an instrument, and I know the lit really well, but
Right.
I'm not a good player. There was really a point at which I had to decide which set of skills to pick up.
Yeah,
There's
yeah.
so much involved in organ building as a trade,
Sure,
so many
sure.
things to learn and to do at a high level. I mean, woodworkers, furniture builders enjoy talking about airtight woodworking, but they don't actually have to do it.
Right.
Organ builders actually have to do that. They
Yeah,
have
yeah.
to
Yeah.
have to cash that check. So, um, yeah, I think my standby excuse for not being a better keyboard player is I was learning to build them instead.
Okay. No, that's fair enough. I don't think you need to play the keyboard. Or play the organ. I was just interested if you could. I think you mentioned when we were talking beforehand that you actually have purchased a smallish organ.
Yeah, it was actually the instrument of my youth.
Okay.
The instrument that my dad composed on was a Yamaha electric organ, which was obviously not a pipe organ. It's
Hmm.
an electric organ. It was the first Yamaha that did the synthesis part digitally.
Okay.
So it was the first wavetable instrument that they ever made. And so the filter section is all analog, but the synthesis section is all wavetable, and it's a
Interesting.
little two manual organ with a short compass pedal board, all
Mhm.
light up controls in the way that Yamaha used to do it. Weighs about 7 million pounds. It's like a hernia in a can.
Okay.
It's just ungodly heavy.
Right.
And it's the instrument that I grew up around. It inspired a lot of my sort of early interest in electronics and music.
Okay.
And so last year, I guess it was in the fall, I got an itch to see that particular instrument again, and went hunting around to try and find somebody who still had one. And a lot of them have been gutted actually, because it has more famous cousins in the synthesizer world that it shares parts with.
Interesting.
And so a lot of people tear them down for parts
Yeah.
when they get retired. But this one had been sitting in the living room of some high school music teacher who was teaching lessons on it for years and years. And he had his receipt from having bought it in the
Wow.
80s, and the demo disc, the demo LP that they used to sell it to him, and like every scrap of paper that had been involved in that transaction was still with it. He's one
Amazing.
of those kinds of sort of obsessive guys.
I'd imagine in very good condition as well.
Yeah, for having been taught on, I mean, that's hard on a console.
Mm.
It's a lot of notes and a lot of people who aren't necessarily trained to be careful yet.
Right,
But
right.
yeah, when I got it in, everything except the reverb worked when I got it in, which for an instrument of that age is pretty remarkable.
Yeah.
It was also like a first generation product for Yamaha, so it was built like a
Right.
tank because they hadn't figured out where they could economize yet.
Mhm.
The whole thing, I mean, it must have 60 pounds of wire in it. I mean, everything is wired point to point, everything.
Wow.
There's virtually no connectors in it. And so it's all soldered in. So, I mean, you can have passives go out of spec, but that's about all that's ever going to go wrong with it. All the amps are all fine, and I have not yet unearthed the reverb to find out what's wrong with it.
Okay.
But it
I was
has a
gonna
spring
ask.
reverb, and
Yeah.
that's the only thing in it that wasn't functioning when it arrived. But it takes 3 men to move the damn thing, to pull it out from the wall, to climb it at the back of it and figure out what the hell the problem is. So I haven't taken the time yet.
Fair enough. Very good. You mentioned earlier when we were talking about the pipe organs that this brought you to electronics. Could we
It
expand on that one?
did. I had a sort of hobbyist's interest and a sort of computer
Okay.
geek's interest in electronics since I was a kid. Dad was amateur radio guy in his youth, so like their guide to building radios, which is the only cheap way to get one, was banging around in the household library when I was a kid. I didn't have the time or the money, or frankly the math to do that. That background came later,
Mhm.
but I was always had an interest. But by the time I worked my way around to having my own organ building shop, I had tinkered a little bit in the early days of the basic stamp. If we remember the basic stamp, and I thought it was interesting that those sort of microcontroller projects were getting within the range of hobbyists. Arduino was just starting to become a thing,
Mhm.
and I went into business building pipe organs, and the control systems on the market were incredibly expensive and shockingly shabby.
Right.
They were, I mean, not in the sense of not being well made, but in the sense of not having had a generation in 10 or 20 years. And
Okay.
those are the wrong 10 or 20 years to miss if you're,
right.
if you're building electronics.
So does this mean that they were unreliable or failed
They were
easily, or
reasonably
were they just
reliable, but I mean,
physically
like,
large? What's the
you open
problem?
this thing up and it's made out of all like 7400 series logic. Like a lot of
Okay.
these systems did not
Yeah.
have microcontrollers in them.
Right.
And it made them incredibly expensive. It made their wiring very laborious. And for this, you have to pay a premium price. They were not cheap. I mean, it's like a lot of sort of niche electronics. This happens everywhere where you're making electronics for a small audience.
Right.
You see it now. Like one of the things that I've been researching lately is assistive technology for people with mobility problems, people who can't type, those sorts of things. So like joystick mice and things like that. It's all, I mean, and not all. It's to a remarkable degree very old, very expensive technology because there is no real incentive to innovate because all of the paths of innovation make the product cheaper and mean that you make less money in a year.
Okay.
So like who wants to do that for a living?
Interesting. Yeah.
And it was the same in the organ business. And I wasn't willing to both pay out the nose and get hardware I didn't respect. So I knuckled down and said, all right, well, if I'm gonna have a go at this, we'll play it for real, and I'll use my own control systems. And so I set out to design and build one, which I did. I think it's still in 3 instruments in the wild.
Okay.
Last I know about those instruments, and it worked pretty well. I mean, there are things I would change about it now. It was the first thing of any substance I designed, but we designed and built it all in house. I built a reflow line for it, which was remarkably forward looking at that time. Heated from underneath, so all of our boards were only populated on one side because it was all. I rigged a temperature controller onto a Presto kitchen griddle.
Right.
So, big slab of aluminum about yay size, half a meter or so to a side. And then I bolted a big chunk of mill aluminum onto it to spread it out. It took an hour to warm up. And then you could just literally move boards onto it until they reflowed and then move them off again.
Okay.
Which worked well. I turned out hundreds of boards that way. But between that and a vacuum pickup, we turned out all those boards. And I must have made 200 or 300 boards that way.
Amazing.
Of various kinds. Prototypes were really expensive back then. It's the thing that strikes me most. I actually, not that long ago, turned up one of those prototypes and remembered that I'd had to pay like $150 for 3, and that it took like 3 weeks for them to show up. Because that's
amazing how it's come down in price, isn't it?
Yeah, that's shocking, the difference that time made. But yeah, that taught me to design, build, field, service the same hardware all the way through, which I think is a great set of skills to have. It's always dangerous to be one of those hardware designers who gets to make the entire life cycle of the thing after your bench someone else's problem. To have to sort of dog food your own hardware is a real education.
Yeah. Did you have to sort of do the selling as well? Was there much resistance in the industry to using your equipment?
There was a bit. I mean, there were some legitimate concerns about, service life, obviously. This thing dies in, 5-10 years. To whom do we turn?
Right.
And that's a legitimate question. And the answer is basically, well, you kind of roll the dice with anybody. I mean, this is not a business in such remarkable shape that the people making these, control systems are guaranteed to still be around when you need, replacement parts.
Sure.
So I could usually allay their concerns by saying, look, I am leaving with you a USB key stick that has 100% of the designs for this. Any reasonably competent electronics person can make more.
Okay.
And the firmware is here, and there are spare parts here. So between those things, like, you are better covered than anyone else is offering. Because like no one else is coughing up design files or firmware or anything like that. So that could usually alleviate their concerns. But I mean, the level of concern when you're talking about like an organ contract, this is often a 6-figure affair.
Okay.
There are bigger things to argue over usually than the control system that you use.
That's fair enough. Very good. And so what happened once you got to the end of your time in pipe organs? And how did that happen as well?
Well, it's, as I say, it's sort of a collapsing business. I got tired of poverty. In the 12 years in which I was an organ builder, I got to a point where I could literally build everything involved in an instrument from raw materials. One hesitates to blow one's own horn too hard, but I was very good at my job. And in that time, I had never broken over the median income in the areas where I had lived.
Okay.
Which is a tough pill to swallow. To acquire that much expertise, to be that close to the top of the skill chain, and to be making, fast food management money was pretty rough. And when the last firm that I worked for collapsed, not well, it's a business. It's a business for obsessives, and it tends to draw people with obsessive tendencies, and not a fair few alcoholics, which was the problem with the last one. And the guy who ran it, who I otherwise respected, power dove the company into the terrain, and decided I was done and would go back to technology. And so, as it happened, I was becoming aware of Hackaday Super Conference.
Okay.
And I was broke, as can be expected. And I was on the East Coast. I'm like, all right, well, I will take a flying leap. This was in June when I left the last company that I worked for, and they had just opened the call for proposals for talks in the fall, because I think it was in October that the conference was. I'm like, well, if they will pay me to come out and give a talk, then I will give out a talk and try and fish that audience for a job.
Okay.
On the electronics side, because I've built and fielded a lot of electronics now, and I can make that case. I don't have any qualifications on paper, but I've built a lot of stuff, so maybe I'll find the right job there. And so I put in a proposal for a talk about wiring, because God knows organ builders do their share of wiring and can talk about that. And they accepted the talk. And so I flew out and met a whole bunch of people and gave the talk, and it was a fabulous time, and did not find a job. So I came back from that one and ended up going to work for a company that makes essentially protective equipment for tablets and computers, so that they can ride around in cars and ambulances and airplanes and that sort of thing.
Okay.
They sell a lot to law enforcement and to EMS and to airlines, and a little bit military, but not that much, because those guys tend to go for bigger names than that. And so essentially the job of, wrapping modern computers in enough aluminum that people don't break them, which is actually much harder than it sounds.
Okay.
But they were looking for someone to work in their electronics department. They were producing all their work in-house, because the owner was paranoid and thought that people would rip off his designs if he sent them out for manufacture.
Oh, okay.
And so he was one of these guys who had taught himself electronics in the 70s and 80s. They were still building everything with through-hole. It was amazing in not always a great way. And so I started for him essentially just in the production department, because it was a foot in the door, and then gradually redesigned most of what they were making into a more modern workflow, and then solved some problems that that era of technology was not ready to solve.
Right.
Bigger switch mode power supplies. It's a weird business, because like the buyers are all as out of touch as the owner was. And so like one of the things that happens at trade shows, this is a famous thing that you'll see happen all the time, is that buying agents will go through and they will see a system, they will insist that you put it under load, and they will finger test it. And if they can feel any warmth, they won't buy it.
Right.
Because they all grew up in the days of linear power supplies.
Okay.
And if you put a linear power supply in an automotive environment where it can get to be like 120 degrees Fahrenheit without much effort, and it's making heat on top of that, it's not going to be reliable, right? Like it's going to cook off all its passives, because those systems in those days all had great big caps in them. And so like they had brought this mythology with them,
right,
into the modern age. And now you're trying to build like modern switch mode power supplies, which sort of get hot as a matter of course, right? Like the components that they're made out of are all designed to deal with that. So you get hot diodes and hot controllers quite regularly, and it's
Mhm.
it's fine, right? Like it's fine, but they can't be persuaded of that. So I spent a lot of time over engineering switch mode power supplies so that they would run at room temp.
Okay.
So like I designed a power supply to run Microsoft Surface tablets in automotive power. And they're weirdly fussy. They have some real strange eccentricities. Even Microsoft stopped making car power supplies for them eventually because they couldn't make it
Okay.
work.
They as in the tablets?
Yeah.
They're fussy, yeah. Okay.
And
Wow.
so I built one that's about 50-watt switch mode power supply that ran passively cooled against a slab of aluminum, and you could not detect heat on it with your hands when it was running full pitch, which is
Right.
so it's on an aluminum PCB. So
Yeah.
it was weird.
Some fun technology to play with.
It was
I guess
interesting.
it
I mean,
was.
it was a real education. Like switch mode
Yeah.
power supply design is pretty esoteric stuff, and I really
Mhm.
had to read up. I wasn't ready for that when I first started. So having a little runway in front of me just in the production department before I had to
Mhm.
do designs was nice, because like that is a whole discipline to herself.
Yeah.
So that was an interesting education, but the pay was lousy and the level of paranoia was hysterical. Like we were sanding the laser markings off of ICs and stuff, and the
Okay.
boss is like, "Oh well, the Chinese are going to steal my design." And I'm like, "My dude, the Chinese do not need your help designing switch mode power supplies. They're
Right.
so much better at this than either of us. Like you
Right.
have no idea." And so I was actively hunting for something else, and I knew the guys from Conservify because I'd met them at Super Conference
Okay.
the year before, and struck up a friendship with Jacob, who's the lead engineer over there, over woodworking. Because when I first encountered him, he was wearing a shirt that advertised a handsaw that we both preferred, because he's quite a good hand tool woodworker, and I just spent
Okay.
12 years doing that kind of work.
Yeah.
And they started looking. They had been sort of doing everything. Like Jacob had been the hardware guy and the software guy and the firmware guy and the web platform guy.
Right. Right.
And they were reaching the limits of what they could really do that way, and they needed a full-time hardware person. And I campaigned them until they let me have that job remote, because I really wanted the job, but I didn't quite want it enough to move to California to get it. So
Okay. How did that go down? Was that a matter of, please can I go remote, and they were sort of a bit resistant, or?
I think they hadn't really considered it before. They had done a
Okay.
little bit of hybrid work. I think this was before COVID. There was some natural reticence about keeping something like that together with hardware, because you got to be moving prototypes across the country back and forth. There are some some logistic headaches involved
Mhm.
in doing it that way. But I think once I got to sit down with them and talk to them about what I thought they needed and where they were doing well and where they were doing less well, I think it became obvious to them that I was the right person for the job, in part because I'd spent so much time eating my own dog food in the hardware space.
Right. Right.
And that was really important to them, because like this hardware goes out into the field, into, swamps and up trees and all that kind of stuff. And like, you can't just make it somebody else's problem. So
Okay.
that was a real selling point. And I think once they got over that hump, it wasn't so big a selling job.
Mhm.
And then we designed that first generation of field kit hardware in a real panic rush, because we wanted to enter it into the Hackaday Prize that year, which we did,
Okay.
and it won.
Oh, fantastic. Well done. Can you give us a quick overview of what field kit is, what it does?
Sure. So the problem that field kit aims to solve is again, the sort of niche hardware situation where the powers that be in scientific metrology and instrumentation have been around forever. They can charge anything they want.
Mhm.
There's few enough of them that somebody would really have to break ranks to bring the price down, and who would
Okay.
do that? Like, why would you want to do that for a living? And so the hardware is not great. It's not very modern, and it's not very good, and it's very expensive, and
Okay.
that makes science more expensive to do.
Mhm.
And so they founded Conservify to sort of take a stab at disrupting some of the technological cruft and making things a little more modern and a little more affordable. And so it's a nonprofit, and the goal was to develop a whole bunch of open source alternatives to some of these very spendy, high dollar commercial metrology systems. So essentially, a data logger combined with all of the electronic front end of whatever it's sensing. So a lot of sort of AFE type work for the analog stuff.
Right.
And
when you say sensing, what kind of thing were you looking at sensing or measuring?
First ones that we had out, the first generation of field kit hardware had a weather module, which did all the sorts of things that you would expect a weather station to do. It had a distance module, which used an ultrasonic rangefinder to measure distances that's of interest to ecology-minded people, because you can watch tides and you can watch river flow come up and down, which is particularly useful in river basins which flood. That's data which you want to get in a sort of dense way, because the way that flooding river basins move is an active area of research. And water chemistry, which in those days was essentially just a wrapper around modules made by a company called Atlas Scientific, hardware we eventually parted ways with and did our own engineering from scratch.
Amazing.
We were happy with what we were getting out of the Atlas modules. So yeah, that was the initial complement. So the platform at the center of that was the initial hardware complement. Then so there's a whole world, of course, outside of that of infrastructure to make it go, the firmware that goes on it, the app that pulls data out of it over Wi-Fi, and the web portal to which all that data goes to be analyzed and synchronized and spit out in some scientifically useful format. So that whole ecosystem is sort of the pitch.
Yeah.
We talked to a lot of people in the early days who had used the sort of traditional hardware and had, gone out into the field and gathered ridiculous amounts of data of one kind or another. And then it became the job of some poor, unfortunate graduate student to try and synchronize it all over the course of like 2 years, trying to get all the data, lined up on the chart and that sort of thing. And that was one of the problems that we wanted to solve. The sort of most of these systems are just going to hand you like an SD card full of CSV files. And that's sort of where the hand-holding stops. And so we wanted there to be a much more robust gathering and sort of analysis and synchronization end to that in the web somewhere where you could do that and where you could share it more practically than sending around, giant data sets in primitive formats.
So I guess the synchronization sounds like one of the key challenges, maybe, as well as the key features.
It can be tricky. I mean, from the hardware perspective, if you're a terrestrial piece of equipment and you have access to sky, synchronization can be fairly straightforward if you can afford a GPS, because you can take a time base off of the satellites and essentially declare victory. It gets a little more complicated if you don't have access to clear sky, and you have to pay attention to the specs of your RTCs and stuff like that. But like, you're also periodically talking to a device that has a really good time base in the form of a smartphone, which is generally what's being used to provision the thing and to set it up to start collecting data. Like all of the control surface for this is through an app. I mean, there is an on-screen menu. You can set it up without a device tethered, but it's much easier to do it through a smartphone. And smartphone time bases are pretty good, even out in the middle of nowhere. And so that helps if you don't have good GPS. And in the last year, we started getting into underwater systems where GPS is no help to you. And so that's a situation where we've had to go to just precision by hook or by crook. And temperature compensated to boot, because the temperature range over which underwater equipment runs is extremely wide.
Interesting. So what kind of frequency or how regularly would someone need to visit one of these data loggers with their phone? Is that something that sort of weekly and it makes it easier to deal with this kind of thing?
You can make that span, the happier everybody gets, right?
Yeah.
Because in a lot of these situations, like we're doing a deployment, working with a partner in Cameroon, for example. In a lot of these situations, the instrumentation is going into areas which are not easily accessible, getting to which is expensive, time-consuming, and sometimes not safe.
Right.
And so ideally, you don't have to do it very often at all. If you can, you'd love to, stick a satellite radio on every single one of them and never touch them again.
Okay.
So anything between I visit this thing every X number of days and slurp the data down, or it runs entirely autonomously in the wild. Any of these are possible with FieldKit.
Okay.
Usually for just expense reasons, and because in the middle of nowhere, radio networks are not so easy to come by. This is not an area of great penetration for the Things network, for example. So usually they end up being visited, but we have high hopes for Starlink.
Okay.
I have to say, they're very, very high energy hardware there, so that it would require a base station that had a hell of a lot of solar sitting on it. But it might be worth it to be able to, say, have a Starlink station at the middle of a whole mess of LoRa radios that we're speaking into the center of it. That's not hardware that's been developed, but it's a thing I'm thinking about.
I forget the name of it. There's another low power sort of IoT centric satellite based one as well.
Yeah, there have been a couple of attempts at that. One of the problems with them is that everyone who goes into the satellite communications business tends to go bankrupt.
Okay.
It's been a big problem in that business, especially the internet connected ends of that business. I think Starlink is the only one that's making money. It's not really clear how much money they're making under the surface, because they're sort of hiding under the skirt of SpaceX as a company. Right. Or the other way around, depending upon how you want to look at it. From the space analyst perspective, you could say that SpaceX's launch manifest is hiding under the skirt of Starlink as a company. Right. Because, most of the mass they're putting in orbit right now is a contract they can't lose. But it's tricky. So the strict answer to the question is as often as you want to. There's and no more often than that. There's 2 gigabits of, depending upon the deployment, we can build it with up to 8 gigabits of flash memory on board. We don't use SD cards as a first storage method because they're terrible and unreliable. And so we have soldered on NAND flash, and that's actually quite a lot at any reasonable data gathering resolution. So you could conceivably, if you had reasonable exposure to sky for a solar panel, leave a FieldKit in the wild for a year or more. Okay.
And presumably that sort of comes with solar and other energy harvesting techniques, that kind of thing.
Yeah, it's cold weather is a big issue for us. Obviously, you can't charge lithium-ion batteries under freezing. So that's a particular difficult part. But for the most part, what you end up with is a FieldKit with 6.5 amp hours of lithium-ion batteries in it and a 50-watt solar panel. Right. And with even remotely decent skies, if the person installing it knows which way to face the solar panel, which is a whole other discussion, you can usually have a system that will run itself more or less indefinitely that way.
Fantastic. Okay. Very cool. So you mentioned that this is sort of targeted towards scientific research, data collection. Are there any sort of other uses for maybe sort of individuals or communities looking to get this information, or maybe education?
Sure.
That kind of thing?
I mean, one of the goals of the organization is to put this technology into the hands of people who ordinarily couldn't afford it or couldn't figure it out. So, like it has high user friendliness quotient as compared to its competition, and it's quite a bit more affordable. And so we like to see it going into the hands of environmental justice organizations, park rangers, all kinds of conservation causes of one kind or another. It's used a lot in education, high school and college curricula on metrology and various kinds of data science. So yeah, it's got a pretty wide audience, which is nice to see. And the designs have a wider audience yet. A greater audience even than that, because a lot of these problems are problems that people have been making a lot of money having solved. Right. Which is one one of my pet peeves, I have to say. I've always been attracted to the areas in technology where you can, push over anthills. I'm a little bit of a hellraiser by first inclination, and so I get annoyed when people solve a problem and sit on the expensive solution as a passive income. And so the fact that now there is a really good low noise, high resolution solution for things like reading pH probes,
right,
and those sorts of things that's documented, like that circuit, that reference circuit will end up in a lot of boards that are not our boards.
fantastic.
And that's great, right? Like,
and I guess that's sort of partly in due to something we haven't, I don't think, mentioned yet, is that this is all open source.
Yeah, this is all open source hardware. We don't necessarily open source immediately, but anything we sell, we open source. So
that's fantastic.
We do like to try and run these designs down to a level of scientific rigor before we open source them, so we don't lead people to build crap that doesn't work.
Yeah, that's fair enough.
that can be a little problematic, but by the time we're comfortable with a piece of hardware, we will reliably open source it. Like all the water sensors are open source, so there's really, in my opinion, no reason for anyone to buy Atlas modules ever again. That's this is me not speaking for the company in this particular moment, because we would never, but I would. I would say no one should buy Atlas modules ever again.
Well done for doing something better than and available and things as well. Yeah, that's awesome.
A particularly rough challenge. That one was a reach.
Was that pH? Sorry, did you say?
Yeah, pH probes. I mean, it's a voltage mode sensing. It seems like it should be easy, but the amount of current that they can source is like a flea fart in a windstorm. So it makes it's the sort of low level of currents that makes really attractive current paths out of like the oils between the from your skin on the surface of the circuit boards.
Right.
You start getting into the the application sheets and stuff. It's like, you shouldn't put solder mask over these traces because it's too conductive. You're like,
okay.
Alrighty then. That sounds like a hoot. So,
what have you done to sort of address that? Was that a big problem, and actually you've come up with a probe of your own design, or
no?
Is it focused on the electronics still?
It's all chemistry, right? Like the problem with the probes not being able to source a lot of current is sort of inherent into how they're designed. So you have to make a circuit that can live with that in a sensible way and survive what we call swamp finger, which is the phenomena where somebody opens one of these boxes up having climbed a ladder to get there and sticks their swampy fingers up into the electronics. And you can't just have readings going all over the place when that sort of thing happens. So in the case,
if you were to design the amplifier circuitry as close to the probe as possible and enclose it, that kind of thing, you potentially reduce the risk.
I have one here somewhere, but the pH one in particular was a sensitive beast, and the way that it works is we have a high precision op amp at unity gain, and the reason why we don't get greedy about the voltage and we keep it at unity gain is so that we can make a guard trace to go around the run that goes out to the probe's connector.
Okay.
So that there's always a signal surrounding that signal trace at the same potential that is buffered. So there's no place for that current to leak to, because everything that's near it is at the same potential as it.
Yeah, interesting.
So that makes it very noise immune, but that does mean that you need to have both a very nice pair of op amps for that job and a very nice ADC, because you're not getting any voltage gain out of this affair either. So you just need the bits to throw at the ADC stage.
Interesting.
To make that work. So it's not the cheapest thing in the world to build, but it's very robust. We did all kinds of horrifying things to it when we were running the Atlas modules. Like, they had to be once, sometimes twice or thrice put through ultrasonic cleaners after manufacture just to generate decent numbers.
Wow.
And if they got at all defiled by the realities of life outside of a lab, they would cease to produce accurate numbers almost immediately.
Amazing.
And but the design that we have here, the buffered design, like, I did all kinds of nonsense. I put soda on it. I shorted traces out. We put it in ovens. I put it in the freezer for a while. I painted all kinds of stuff across the traces. I mean, it was a horror show. Things you should not do to precision analog circuits, and it shrugged it all off. It's really been a champ.
Amazing. Well done.
You pay high dollars for op amps, and you really do get your money's worth. Cheers to the boys at Texas Instruments, because I was very impressed by both of those op amps.
Great. So have you got anything that we could perhaps see from Conservify? Is that
Sure.
something you'd be willing to share with us?
So your typical field kit looks like this, and the thinky bits in the screen are up here. We built it in sort of 2 layers, mostly just to fit in smaller enclosures. So there's some power management on this board underneath. In fact, I can take them apart so you can see. So there's microcontroller and flash, and there's a super cap there to run the RTC, and a screen that's just an OLED that gets seen through the front. And there's some side mounted buttons there on the bottom, and then down here it's mostly power management and the GPS and the radios. So solar regulation, of sort of very naive attempt at small scale MPPT, which is going to get much better a little later on. We're working on the next version of that mess. Nice. And then essentially just a backplane that addresses the various sensor modules, which are applied with these really wacky connectors, which I'm very fond of. These are regular 2.54 mil pitch header connectors, except that they're open all the way through. So there are holes in the board, and you can stab them right down onto the headers, board and all, and it comes up flush on the outside like that.
Very good.
Isn't that wacky?
That is cool.
And
is that did I see an LED underneath a bit of exposed copper?
Yeah, there's an LED under the corner of each module, which is why the solder mask is stripped back there. We use that to indicate status when somebody is standing at the thing. What you don't want in a system like this is for somebody to walk away from it thinking that it's working properly and come back a month later and realize that they goofed something up.
And they got nothing back.
Something wasn't connected, or that sort of thing can become very costly. So we invested in some ways to make those signals pretty clear. The LEDs actually came late, but I think they were a good addition. And then to make the module design easier, there's actually an I2C multiplexer on this backplane, so that the address structure on all those modules can be the same. You can put 4 of the same module with the same addresses in there, and it works just fine.
That's awesome.
And like on every module, there is an EEPROM, and that EEPROM is the same on every module, and it has information about what that module is and calibration data and stuff like that. And you don't have to worry about address space collisions.
Automatic identification is awesome as well. So
they'll actually hot swap. If you're running the field kit, you can plonk a module down in there, and it will figure out what's there and
awesome
and address it, which is nice.
That sounds brilliant.
Some of that architecture will probably change in the future. There is essentially one I2C multiplexer that will do this job. And it can become scarce in the marketplace. We're all dealing with the joys of supply chain collapse. And so on Field Kit Underwater, which in some ways is a successor to that design because it came a little later, you can just about see there's no multiplexer on Field Kit Underwater for the differences between these water chemistry modules. Instead, we essentially just use I2C buffers. And I2C buffers are usually smart enough not to interrupt a packet midway through, which makes I2C buses very unhappy. But there are way more I2C buffers that are smart than there are I2C multiplexers. So essentially, if you just put every one of them behind a buffer and only turn one of them on at a time, you can achieve the same effect and have a design that's more resilient to supply chain problems than using the one and only 1 in 8 out I2C multiplexer that exists on the market today. So that sort of thing. There's been a lot of sort of redesigning around supply chain resilience in the last few years, as you might imagine. My job is to be Mr. Good News in every meeting about the stuff that we can't get and can't make because we can't get. So it changes the way you design for sure.
Yes.
It tempts you to be a more of a disintegrated engineer.
Mm-hmm. Very good. So those of us listening along might have noticed that we didn't talk about uni or anything at all. Can we just talk about your education background? You mentioned you were homeschooled. Just a bit
I
more
was
insight into that and how
homeschooled
that
through
went.
what would have been a high school, a GED level, and so long as I was, checking the boxes and passing the curriculum, my parents more or less let me go wherever my curiosity took me. So I was quite used to self-education,
Mm-hmm.
and we were also, to put it delicately, not in the economic strata for whom college was a foregone conclusion, or in my case, really a practical option.
Right.
I started working full-time at 16. I never stopped.
Okay.
So that was not really in the cards. So because I ended up in electronics mostly to fill a need in my own business, I didn't feel the need to try and go get credentials to do that. I knew I could build what I needed, and then it really only became a question when I had to go and find a real job.
Okay.
It can be tricky. Like I'm on the East Coast of the U.S. A lot of the electronics work out here is for the defense industry. I have mixed feelings about working for the defense industry in general, as many engineers do. But one of the problems with it is that they are still very much in the degree mindset.
Okay.
Where it's very hard to get a gig in electronics if you don't have little letters after your name that indicate that you know what you're doing, and no amount of having done the real thing will avail you.
Mm-hmm.
So I was a little concerned. I have to say that Conservify took. They say that they didn't consider it a risk having talked to me, but on paper it certainly looked like a significant risk.
Okay.
Having their first full-time hardware guy be essentially self-educated.
Right.
I think, I don't know, you meet people with a variety of opinions about this. There was a long time during which I didn't call myself an engineer because people got very bent out of shape about it.
Really? Okay.
There are places in the world where I wouldn't legally be permitted to call myself an engineer for lacking the degree. I don't have much patience for that kind of gatekeeping, I have to say. I wouldn't want a pacemaker that I had designed. Let's be clear. But it's not the degrees that make the pacemaker safe, and it's the certification and the testing that they go through.
Yeah, absolutely.
So I've never had much patience for people who are fussy about it or snobby about it. Mm-hmm. Part of the perspective for that is, like, I had been in graphics design when the sky was falling.
Mm-hmm. Okay.
I was in printing and graphics design when that field blew up because of desktop publishing. Mm-hmm. And suddenly all kinds of people who had never gone to college for 4 years to learn, color theory and read Binghurst's, The Elements of Style or whatever, were being permitted to design things for print. And oh my God, you would think that the apocalypse was upon us, the Amazing. Way that people dealt with that nonsense. We were being told regularly, this was a thing. I probably still find the article somewhere. People will die because of poorly designed road signs by non-credentialed graphics designers. Was an argument that was seriously proposed. It's like, I had seen this freak out before in my life. It was very familiar to me, the sort of policing of territory by people who'd spent good money on a degree, and by God, they were going to get their exclusivity out of it. So I mostly just find it funny. I have to say, I much less frequently encounter those sorts of protectionist attitudes lately.
Okay.
And I think for the same reason that it ultimately happened in design, which is just there's demand for so much more of it than can be supplied by the credentialed graduates.
Right. I was going to ask if maybe it was a sort of a point in your career where actually you got to a point where you can prove that you can do it, and therefore it becomes less important.
Sure. I mean, it was never important to me.
In the industry.
It was sometimes important to other people, but I never. imposter syndrome is not baked into worrying about not having gone through the formal education. What was instructive was to meet graduates and realize how many things I had always assumed they learned in college they didn't.
Right.
I was amazed in retrospect to discover how much time they spent on Maxwell's equations as compared to, say, how to read a data sheet.
Okay.
Or spec parts or lay out a PCB. It's remarkably easy to get a 4-year EE degree and not build anything.
Yep. Yeah.
And so by the time I was having any of these conversations, I usually built more hardware than the person who was telling me that I shouldn't call myself an engineer. Sometimes a lot more.
Yeah.
And so I was never tempted to take that argument seriously. Like it did not strike at any insecurity in my core. The people who make me feel like an imposter are the people who are naturals and have the sort of natural aptitudes and gifts that just make you feel like you have to do everything the hard way. Ben Krasnow, Ben Krasnow is a friend. Ben Krasnow is a friend of mine, but he can turn his mind to anything and just seemingly absorb it or already possesses it somehow.
Yep.
Like he's, like he's Mozart hearing the music rather than composing it, and it's frustrating as hell. But that's the sort of person who, will give me imposter syndrome, not so much a person brandishing their diploma. That's not particularly a meaningful yardstick to me.
I think that's good to hear, and I'm pleased that you feel that
way. People who I would be, nervous to be in a room with are people like Lamore Freed. Like I learned board layout by cribbing from Lamore Freed for the most part. Like I spent a lot of time poring over her board designs, and she's so good. I remember when I met Brent, who works obviously for Lamore, I said, what is it like to put a hardware design in front of Lamore? I would be terrified to put a design in front of Lamore. And he's like, well, you've seen what Lamore does, like you should be. I don't think she's mean, but like those are the sorts of people who will make me feel like an ant. And it's nothing to do with qualifications. It's to do with capabilities. That's always meant. It's always meant more. And I come from a line of outsiders that way. Dad's a classical composer. He did not come into that with the credentials that are traditional in that business either. So it never really struck me as a thing to be worried about. The math was tough, I have to say. I had a reasonably decent math self-education, but I had to do a lot of it over again to work as much math as is required for the gig. And I got by on faking it for a while. But by the time you're designing switch mode power supplies, the capacity for faking it has gone right out.
It's gonna go down, yeah.
That's you're not gonna bluff your way through switch mode power supply design. You're gonna end up with very, very poor results. So I had to give myself some remedial education on that, and that made me feel like a bit of a rube. But for the most part, I think it would be better if the focus was on what everyone has to offer. I think the best thing about this age in electronics is how many problems that are not a large corporation wide can now be solved because it no longer takes the resources of a corporation to take an interest. So a lot of niche interests can get solved because you no longer have to justify dropping $250,000 on anything that moves. And that's to be celebrated. And the diversity of sort of backgrounds and viewpoints is also useful and to be celebrated. And I try and gravitate towards communities that appreciate that rather than try and stomp it. It's one of the nice things about Super Conference, Hackaday's regular conferences. It's a very open-minded crowd. It's a very welcoming sort of collegial atmosphere. Nobody at a Super Conference ever tried to. I've never seen anyone at Super Conference try to make anyone feel small. At the very first one I went to, I struck up a conversation with Ben Krasnow, who I knew at that point just barely a little bit online and mostly by reputation.
Okay.
We had a couple of friends in common and had a totally, peer level conversation with him where it would not seemingly have occurred to him to assume anything less than, his own superhero-like knowledge on the part of everyone else in the conversation. And that was really refreshing. I mean, that's certainly not universally the case.
Sure.
I have to say young people coming up, especially from non-traditional backgrounds, could do a lot worse than going to that conference. It's a shot in the arm. It was certainly one for me. That conference changed my life.
Very good to hear. Yeah. We linked your PEV talk from the recent conference.
That was a fun one.
That was very interesting to hear. I love some of your viewpoints on things that you shared there.
Yeah, it was the second time I'd spoken at that conference, and it was a funny journey because the first time it really was, that's an experience that will make you feel like an imposter, is getting up in front of that audience to give a talk. Your first time at that conference, coming out of another industry. That was pretty spooky because I didn't really know what to expect from that conference. And I realized that like in the audience and Disney Imagineers and SpaceX engineers and, every imaginable, way of being out of your depth and like, okay, now I'm going to get up in front of all you people and teach you something. That was an experience, but the sort of the journey from there to winning the Hackaday Prize, which was obviously the best shot in the arm to the ego that you can imagine, to then coming back as a speaker again, was a really interesting one. And I felt like if I was going to talk to that audience, that very remarkable audience, I didn't feel like I could just do a show and tell. I felt like that would be a waste. And so I had to give a little bit more of a message talk than that, at least at the end. And that's always a little bit dangerous because it can come across preachy. I think Nick Poole, actually, who you've interviewed, I was talking to him. He was at that conference. He was at that talk. And he said, well, the margin between preachy and inspiring is whether people actually want to hear what you're laying down.
Yes, that's
and
fair.
I think that's largely correct. So I was fortunate. The response to the talk was very positive, but I was a little sweaty palmed going into it because it does end with a pretty direct call to do something useful with all these skills that we are all privileged enough to possess. That's a message that can land wrong or right.
Yeah. Very good. Well, I think we're kind of nearly at time now. Is there anything else you'd like to shout out about or show off quickly before we close up?
Not particularly. I've always, enjoy these sorts of things. I like talking to you. I've enjoyed all the ones that you've done. We had to think about who else we can get into the fold here.
Oh.
But,
any guest recommendations? Much appreciated.
Yeah, we'll talk about that after. See who we can get. But I would just say, one of the things we talked about, Sam and his organ project earlier. The thing about him that inspires me the most is his recurring motto of "Don't be afraid to try it." If I'm going to go out of this interview on a message, it would be that one, right? Like I think there's room for a far broader range of backgrounds in electrical engineering than is maybe traditionally considered. I'm glad to be alive in a period where that's being acknowledged. And I would say if there are problems that appeal to you, there's nothing quite like having the right enemies. Spite-based engineering, as Lamore Freed likes to say, is a very powerful force. And follow your annoyance and dethrone people who don't deserve the money that they're raking up. It's deeply satisfying.
Fair enough. Well, thank you very much.
Thank you.
That's fantastic. We'll be talking with Tom Fleet next week. But otherwise, it's goodbye from us. Thank you very much for joining us, and we'll see you around.